This week in lab, you're going to do an experiment that involves you preparing a solution. And what you're going to do is take a stock solution that will be provided to you, and you're going to dilute it down so that you end up getting different concentrations. Well, so the starting solution or the stock solution that they're going to give you will be of a certain molarity. So remember what molarity stands for, moles of the solute per liter of solution. And then you're going to take a small portion of it, add some water, and then you will have effectively diluted the solution because now your amount of moles of solute for a greater volume will then be reduced. So you're going to have a diluted solution. So the formula that we're going to be using is a real popular one. It's just called the dilution formula. Need to remember what it's referred to or what it's called. Some people will write it M concentrated, just an abbreviation for what the more concentrated or the starting solution is, times its volume, like how much of that solution you would pour out. And it will be equal to then the molarity or what that resulting concentration of the diluted solution is times whatever its volume is. So you want to remember that formula. Sometimes you'll see in my practice problems, I'll just use ones and twos. And so it doesn't matter if you put little c's or d's or ones and twos. Okay, that's a simple dilution. There's also something called a serial dilution, where you may be familiar with this more in biology. It's more of a biochemical application, where you take one solution and you're going to dump some into a test tube and then dilute it down. Then you take some of that solution and dump it into another solution and dilute it with some more water further. You'll see what's ended up changing is that you're diluting the concentration by a specific factor each time. We're going to be doing just the simple dilution, so you're just going to be mixing up separate solutions that are of a certain concentration. Okay, so let's work through two examples. One, at the bottom of the first page on your handout, is just basically plugging the numbers into the formula and seeing how this all works. So the way that I've got this first problem set up is asking for what volume of the original concentration would be needed if you wanted to end up with a total of 500 milliliters and you want the concentration to be 0.25. So does everybody see how that your starting concentration, that's the more concentrated one. In other words, you have more moles per liter. You want to dilute that down. So you take a portion of it and you're going to add some water, and that effectively then dilutes the concentration or lowers it. And we want to end up having 500 milliliters total of that original, or I'm sorry, of the final solution. So you just simply plug the numbers in. That's your final volume that you're going to end up with. That's the final concentration or the second or the more diluted concentration that you want. What we're essentially saying is how much, that's the volume, how much of that original solution would you need in order to end up then having 0.25 molar and 500 milliliters. When you crank it out on the calculator, it's going to spit out 20.8 and then 3, on and on and on. So remember, it's going to be based on 2 sig figs. Here, the 0.25 and the 6.0, that's going to be 2 sig figs. So you're going to end up needing 21 milliliters of that 6 molar concentration. Now think about what this means or what that represents. Is that what it's saying is that you're going to end up having 500 milliliters of solution. You would have only added 21 milliliters of the initial 6 molar one. So what it's effectively saying is that you take the 21 milliliters of that 6 molar concentrated solution and you're going to add 479 milliliters of water. That gives you a total of 500 milliliters. That concentration then of the solution now is only going to be 0.25. In other words, you went from 6 molar concentration to only 0.25 molar concentration. Now, problem number 2 on page 2, this one is nearly identical to how the setup of your lab experiment is going to be this week. And again, you're going to use that formula. The only thing that's different is I changed the concentrations, I changed the initial volume of the solution that you're measuring out, and I changed the identity. This is sucrose. I made up an example with sucrose, and you guys are going to be using cobalt-2 nitrate. So this is going to be just a 0.55 molar solution of sugar, so sugar water. It says to obtain 30 milliliters. That's just so that you don't have to keep on going back and forth to the bench. So whatever your lab manual tells you, it's just to save you some time. What you'll be doing is using a burette to measure out in 4 separate beakers, 2 milliliters of that solution, and then in a separate beaker 4, 6, 0.8 of that solution. And then look what you're going to do is you're going to then dump in 8 mils, 6, 4, 2 in respectively each of those different beakers. So where am I getting that each of the solution comes out to be 10, and this is what you're going to be doing in lab as well, is that in beaker number 1, it had 2 milliliters of the original 0.55 molar solution, and then you're going to add 8 mils of water. So see how each combination is going to end up coming up with 10 milliliters. Now in lab, things aren't going to, necessarily go perfectly. So you're just going to be adding the two volumes together and you're shooting for something that will be close to 10. But, who's going to exactly get 2.00 and who's going to get exactly 8.00 for your volumes of your two liquids? You just add the two together, but you're all going to be in the neighborhood of having 10 milliliters for each solution. So the idea here is, how would you figure out the concentration then of each solution? Well, so in the first one, in your first beaker, that's the one where we measured out 2 milliliters of water. That was the initial concentration. So see how this is our molarity of the more concentrated solution. This is the volume of that concentration solution that you measured out. Then you added 8 mils of water. So then notice how then that's going to be your final volume, or that's the volume of the diluted solution, is going to be 10. See how that's the same for all of them because you just added the appropriate amount of water so that it brought all of them to 10. Or remember whatever your two volumes are together. Your lab instructor will go through this with you as well. And then you could solve for what that brand new concentration is. So 2 milliliters being then diluted to a volume of 10, in other words, 2 of the original, and then adding 8 mils of water. Notice that what that did then is it just diluted the concentration by a factor of 5. It's going to be then now 0.110, so a lot less than 0.550. Same thing for solution 2 and onward. So for solution 2, this is where you then had put in 4 milliliters of the original solution, just that same original stock solution, so of the original 0.550, okay, and then added 6 mils of water, so that there again you're going to end up with 10 mils, and then when you solve for that concentration, it'll be 0.220. Hopefully you all see how that you end up having in this solution something that is twice as strong, so to speak, or twice as concentrated as the solution number 1, because you started simply with more of that particular solution. So your solution ends up having more moles per liter. Solution number 3 then, you can probably catch on. See, you just take, that's now 6 milliliters. Again, adding 4 mils to give you a total of 10. So now your concentration is 0.330. And then solution number 4, 8 mils, only adding 2 mils of water, right? See how that one ends up getting the one that's the most concentrated? Because now you had the greatest amount of volume of the original solution, moles per liter, being diluted then not very much, right? This guy only got 2 mils versus all the other ones, and so his concentration is the largest. So just like any other formula, though, that we've ever had in science and chemistry, is that you have the 4 different values, be able to plug in the information for any 3 of them, and then solve for any of the variables. So this is just a good practice, and you get to do it in lab this week. Now, last but not least then, you have for page 3 a problem that is a serial dilution, where you take solution number 1 and then you're going to dilute that one down further, and then you take that solution number 2 and you dilute that one down further, and so forth and so forth. So page 3, that is going to be then a bonus problem. So that's in your handout, the very last page. This will be due Friday. It'll be due this Friday. So all you have to do is just tear off that last page with showing your work, where all your numbers come from, all your units, sig figs, all that normal stuff that we've been doing all semester long, and you can turn that in for a maximum of 5 bonus points. And if you have any questions, of course, you can ask me on Wednesday or in email.